Leetcode question 253 here, meeting room 2, and it's a median Leetcode question. Basically, they give you a meeting array intervals where you have two number. First one is the start, and the second one is the end of the meeting. Return a minimal number of conference room that is needed. Looking at here, 0, I have a meeting run from 0 time to 30, and another meeting from 5 to 10, and 15 to 20. So visually that we can see here easily, you need one meeting room for 1 to 30, right? And then the second meeting room to 5 to 10 and 15 to 20. It's pretty easy to see here. Your goal is to write a function to process this to return the output as 2. So here, 7 to 10 and 2 to 4, and you can see that the thing is not they're not overlap with each other at all, because 4 is actually smaller than 7. So in the end, you only need one meeting here, one meeting room, and here's some constraints here. And the company asked this question in the last 6 months. A bunch of companies asked this question. Definitely a great question to get familiar with. And the best way to solve this question is actually using a structure called minimal heap. And let's take a look at the example. Maybe this way we'll do it see it more clearly visually. And let's say a meeting start from 0 to 30, and there's another meeting room to 5 to 10 and 15 to 20, right? How do we know it needs meeting room 1 here, meeting room 2 here, right? That's what the minimal heap data structure is for. I'm going to show you how to do this, and basically the minimal heap is the result, and I'm going to store all these numbers to compare all these numbers for the beginning and starting time. And if in the end, whatever I processed in the minimal heap, the length, the count of the numbers will be the meeting room that is needed. And I will explain to you why when we go along each different numbers. And you can see very clearly is that if my start number is smaller than the end number, that means I need another meeting room, right? Because it's totally different. I'm not able to do the 2 meeting in one room at the same time. And if my end time is smaller than the start time of the next meeting, that means they're not overlapping, and then they can totally use the same room. That's why the minimal heap is so useful. Let's start processing all these numbers. And one key factor is like if they give you numbers like this, you want to make sure the array that they give you is sorted so that it will be easier and accurate when you compare these numbers. So after sorting, the array will become 2, 4, 7, 10, so that you can compare the number between 4 and 7. And 7 is bigger than 4, and they're not overlapping. If they're not sorted, then you will not get an accurate result, right? So in the first example, 0, their first number is already sorted. You can see 5 is bigger than 0, 15 is bigger than 5, so which is good already. So I'm not going to shuffle the sequence, but I'm going to show you how to process these numbers together. So in the minimal heap, what I'm going to do, the most important thing is I'm going to append the second number, which is the end time for the first meeting, in the minimal heap first, because so that I know when the first meeting will end for the first meeting, then I can compare it with the beginning of the second meeting time. In this case, when we look at 5 is smaller than 30. So that means that they are overlapped. They would not be held in the same meeting room. It's purely impossible. If 5, so we're going to compare the first number in the second element, right? And if 5 is smaller than 30, that means that I need another room. And so that means I need to append this set into my minimal heap. Remember, the length of the minimal heap, basically the count of the element, is the answer that we need, the meeting room that we need, right? So if 5 is smaller, then I'm going to append this value to to this minimal heap. But the thing is, when I append, right, I don't append the beginning of the start time. If I append the start time, how can I compare with the next meeting, right? When I append to the minimal heap, I always want to append this number, which is the second number, the end time of the meeting, just like how I append the end time of the first meeting, right? So that I can compare with the beginning time of the next meeting. So since 5 is smaller, I'm going to append the end time here. So 10, right? And one really nice thing about the minimal heap is that when you append 10 to the minimal heap, it will automatically change the sequence and shuffle pop the minimal heap, the smaller value to the top of the minimal heap. And then when you actually pop the value, it will start popping from the smaller one. That's what's nice about the data structure. And then so the queue currently look like this, right? By this time we have already processed the second meeting 510, and now we're gonna process the last meeting, which is 15 and 20. And if you look at a 15, is 15 smaller than the first number in the minimum heap? No, it's not. It's bigger. If it's bigger, that means I can hold the meeting in this room, right? I basically don't care about I don't need to remove anything because it can be held by the same meeting room. If this number is bigger than this number, what I'm gonna do in this step is that I'm gonna pop this value, basically pop this 10, and I'm gonna append the ending time of the meeting, so which is 20. So the minimal heap will look like this. That's how it works. And after I process the third meeting, that's all from the array, right? And then if I look at the minimal heap here, it's 2. The length is 2, 20 and 30. There are 2 meetings here. And for example, if I have another meeting 35 to 40, so I have a 35 to 40, and I always compare with the smallest number. Is 35 bigger than 20? Yeah, it is. So I'm gonna replace this 20 with 40, and when I add 40 to the minimal heap, it will automatically shuffle to something like this. And so when I pop next time, it will try to pop the smallest number. If I have a meeting at 36 or something like that, it will try to add to the 30s meeting room. And then if you look at the end result, you basically only need 2 meeting room for this case. I hope it all makes sense to you, and then I'm gonna show you how to do this in code. Code is pretty straightforward, so we're just gonna, if not intervals, we're just gonna rule out some edge cases, and then if no intervals at all, we just return 0 room because there's no room needed. One thing really important I mentioned at the beginning is that we need to intervals.sort. We need to sort the array first, right? So that we can compare the beginning of the second meeting with the first meeting more accurately. And then I'm gonna set a result that's basically the minimal heap that I'm gonna pop from, and I'm gonna say heap q and heap push. I'm gonna push the first so I'm gonna push the second number in the first number set in the array to the minimal heap, basically push to the result first. That either way, we will need a meeting room, right? So intervals, and that's 30 is basically the 0 set. The index for the 30 is the first, basically index 0, and the second element index is 1, right? So it's intervals 0, 1. So by this time, I already append the 30 to the minimal heap. And then for I in range, or for I in intervals, I don't need to set range or anything. I want to start, so I'm going to process for I is basically this set and this set, right? So I'm going to process every single pair starting from the index 1 for the rest of the elements pairs in the intervals array, right? And then so since I already I start from 1, so the first one I'm processing is actually I is this 5 and 10. So what I did was, if the result 0, because it's a minimum heap, the smaller number is always on top of the minimum heap. Basically, if the first number in the minimum heap is smaller or equal to I0, that's the second case. Like when we have the 10 here, if the result is smaller, the 10 is smaller than I0. I0 is the first number, 15, right? If it's smaller than the 15, what I'm gonna do is I'm gonna start popping from the minimum heap. Heap kill dot heap pop res. He popped from the result, so that's why the 10 got popped. And after I pop the 10, I'm gonna update the minimal heap with the and value in the 15. Even it's not smaller, even it's bigger, like in the second case, I'm still gonna update it. So that's why I'm gonna do heap q dot heap push and the result, and I'm gonna append I1. That's basically the second number in the pair that we process every single time, right? And in the end, I'm just gonna return the length of the result, because that will show us how many meeting room that we need. That's basically it. Okay, I hope this is helpful. Let me know if you have any questions. And please like my video and subscribe to my channel, and I'll see you soon. Bye bye.